My name is Zhuo, and I come from Deloitte as a Google Cloud Specialist Lead and Deloitte Certified Chief Architect. For today's presentation, I'm going to talk about protect APIs using Google Apigee X and architecture best practices. For today's agenda, I'm going to start with the problem statement and then talk about what Google Apigee in general can help. And then we talk about architecture best practices. After that, I'm going to zoom into Apigee X. And at the end, I'm going to do 2 demos. The problem statement is that organizations are faced challenges on API management from 3 different perspectives. Number 1, API security. How to secure APIs by providing features and such as API keys, OAuth token, rate limiting, and threat protection. How to monitor APIs for potential security breaches and respond to them in real time. Second, API analytics. How to get detailed analytics on API usage, including traffic, performance, and error rates, so they can optimize API performance and improve the developer experience. Third, API lifecycle management. How to manage the entire lifecycle of APIs from creation to retirement. This includes versioning, documentation, and API deprecation. Overall, Google Apigee can help organizations to do all of that: build, manage, and optimize their APIs, leading to security at scale, faster time to market, and improved developer experience. Apigee is a platform for developing and managing APIs by adding a proxy layer to your service. Apigee provides a facade that helps you to secure your backend service APIs. You can use different security mechanisms in an application, such as API key or OAuth 2.0 with transport layer security. You can also add rate limiting and threat protection policies to the backend of your API layer. And Apigee has out-of-the-box default policies to secure your APIs. For example, in this table, you can see there are quite some, it's not all of them, but I listed some of the security policies that will help you to control access to your APIs. And the traffic management policy helps to configure caching, control quotas, mitigate the effects of spikes, and control API traffic. And also, message level protection policy lets you inspect and validate request payloads to help protect your backend from malicious attackers. Let's look at this initial architecture diagram. And then let's look at any constraints it's bringing to from the security perspective. In this architecture diagram, you can see I have payments and accounts service are hosted in the data center. The money transfer service is hosted in Google Cloud. And foreign exchange service are hosted in third-party sites. And I have HTTP load balancing, controls and configures the ingress to the services. HTTPS load balancing forwards the request to the appropriate backend or third-party services and handles the TLS handshake. But in this initial architecture design, and there are several constraints. It is unlikely to protect a system from malicious attacks. It does not reflect consistent best practices for security and logging because these services are developed and maintained by different teams within the organizations. It is difficult to set rate limiting, quota, spike arrest to protect downstream APIs. And without API analytics, it is hard to measure and optimize API performance. So I listed lots of constraints. Then let's look at architecture best practices using Apigee and other services from Google. And Apigee can make it easier to expose your services to your consumers by implementing a standard set of security policies across all APIs. This diagram shows the initial architecture with the addition of Apigee as a proxy layer. So if you look at the traffic flow, the client sends the request to HTTP load balancing with the credentials for the application. For example, an OAuth token. Then HTTPS load balancing routes the request to Apigee. And Apigee processing the request executes the security policy and allows or denies the request, routes the request to the different backends. And Apigee forwards the request to GKE backend directly through internal IP address. The communication between Apigee and the money transfer service, which is here, can happen over RFC 1918 address, which is an internal IP address, because they are within the peered network. And Apigee sends the request to the private data center backend through Cloud Interconnect. And Apigee sends the request to third-party service through Apigee NAT IP address provision. While Apigee X includes OAuth token, API keys, and many other API level security features, Cloud Armor offers network and application security. Cloud Armor is a part of the Google Cloud global load balancing infrastructure. It provides web application firewall capabilities and helps to protect distributed denial of service attacks. It's also called DDoS attacks. It can also help you to mitigate the threats to application from the risk listed in the OWASP top 10. You can configure rules and policies in Google Cloud Armor to evaluate every call made by the client that hits HTTPS load balancing. With Apigee X and Cloud Armor, you get integrated security capabilities to protect APIs at multiple levels. And this flow of events in the architecture is similar to those discussed in previous slide. Use Apigee as a proxy layer. So the client sends the request to HTTPS load balancing with the credentials for the application, for example, an OAuth token. And the Google Cloud Armor filters the request because HTTPS load balancing has it enabled. It enforces and evaluates all the configured rules and policies. If any rule is violated, Google Cloud Armor rejects the request and gives you an error message and a status code. If there's no Google Cloud Armor rules violation, HTTPS load balancing routes the request to the Apigee. And then Apigee processes the request, execute the security policies, and allow or deny the request. It routes the request to different backends, just like previously we described. Furthermore, to further enhance your security profile, you can also add Recapture Enterprise. It uses an adaptive risk analysis engine to keep automated software like bot from engaging in abusive activities on your site. You can set application to load the Recapture Enterprise libraries to generate a Recapture Enterprise token and send it along when they make a request. So in this diagram, you can see the client sends the request to HTTPS load balancing with the credentials for the application, for example, OAuth token. And then it flows through HTTP load balancing and then goes also in conjunction with Cloud Armor. And then for website calls, such as a form submission for a login page, Google Cloud Armor is integrated with Recapture Enterprise. And Recapture Enterprise evaluates the incoming traffic and adds risk scores to mitigate the traffic. For traffic that is not legitimate, Google Cloud Armor can deny the request and send a false response code to the user. And if there are no Google Cloud Armor rule violations, the HTTPS load balancing routes the API request to the Apigee. And then Apigee processes the request, executes the security policies, and allows or denies the request. It routes the rest request to the different backends, as we described it before. So that is the part of the when we see Apigee, how do you apply Apigee and in conjunction with other Google native service, for example, Cloud Armor and Recapture Enterprise to protect your API downstream API. The next session, I want to zoom into the Apigee X from the Apigee API management perspective. In this table, you can see there are several Apigee products. And for today's discussion, I'm going to focus on the legacy Apigee Edge for public cloud and runs in Apigee Cloud versus Apigee X, which runs in Google Cloud, a newer version, and both of them are managed by Apigee. If I do a comparison between both, Apigee Edge and X, both are API management platform provided by Google. And architecturally, Edge is based on a monolithic architecture, and X is based on modern microservice-based architecture. From deployment perspective, Edge is deployed in Apigee Cloud, and X is only available as a cloud-native service on GCP. In terms of provisioning in Edge, Apigee Ops team do it for you, but in X, you are responsible for configuring it. In terms of a feature, X offers new features and capabilities, and X also offers new policies. In terms of IAM and RBAC, Edge use Apigee IAM and RBAC, and X use GCP IAM and RBAC. Now the question becomes, why move from Apigee Edge to X? Well, Edge is a legacy product that was developed by Apigee, which was later acquired by Google. And Apigee X is a newer cloud-native platform that has been built from the ground up to provide advanced API management capabilities. Organizations are moving from Apigee Edge to X to take advantage of these advanced capabilities and to benefit from improved performance and scalability of the cloud-native platform. Furthermore, we can zoom into inside Apigee X. Here, what you see is basically infrastructure architecture diagram. And from this side, Google manages Apigee X runtime in Google VPC. And you have a customer VPC to manage, which is here. VPC network peering enables communications between VPCs, and manage the VMs or manage the instance group allows request and response to flow between the peered networks. And the traffic route privately to a workload in your internal VPC. So if you look at the flow, a client app calls an Apigee API proxy. The request landed on a global L7 external HTTPS load balancer. The external load balancer is configured with an external and a public IP and a TLS certificate. The external load balancer sends request to a virtual machine. The virtual machine serves as a bridge between your VPC and Google's VPC. The Google's VPC is certainly managed by Apigee. The reason we do this kind of configuration is because the global load balancer is not capable of communicating across the peer networks. A VM, on the other hand, can be configured to talk to Apigee across the peer network. That is why we're provisioning a managed instance group of VMs to function as a network bridge. The VM sends the request to the Apigee, and which processes the API proxy request. And the Apigee sends the request to the backend service, and the response is sent back to the client. Now, in these days, people are more leaning towards not using VPC peering, but instead of using private service connect. And I did not draw up another diagram, but it will be like this. You will have a service attachment here resides in Google VPC. And on this side, you will have network endpoint group and peered through peered through private service connect for the northbound traffic. And private service connect with network endpoint group configuration lets you to send Apigee API proxy request from any network enabled machine. If I have a different project, I can also send the traffic into this service attachment and rely on this Apigee instance. Next, we are going to talk about multi-region. And you can expand an Apigee organization across multiple regions because multiple regions expansion allows additional benefits. You will get high availability. In case of a region failure, traffic can still be served by the remaining regions, increasing the overall availability of your APIs. Another benefit is that high capacity. Additional regions provide extra capacity for serving your API traffic and a room for any unexpected spike in traffic without adding much pressure on a single environment, increasing the overall capacity of your APIs. Third benefit is that low latency. Additional regions can lower the overall transactional latency for clients by serving the request in a geographically closer region. So to add a new region, you must create an entirely new instance in this region. For example, like here, in region 2, I added another Apigee runtime. You will create a manager instance group in your project, which is here, to communicate with a level 4 internal load balancing deployed in the region where the new Apigee instance resides. The managed instance group proxy for all regions are connected to global external load balancing's backend. Alternatively, you can also create using private service connect. You will create a network endpoint group here and here, and in your project that communicate with the service attachment, which resides here and here. And the service attachment in the region where the new Apigee instance resides. And that is through private service connect. That's another way to control the northbound traffic, as we talked about before. I want to talk about shared VPC. In an enterprise environment, shared VPC is very common. And what it benefit to you is that you can do a VPC peering between your Google VPC with your shared VPC network. And your backend API will use some subnet of this shared VPC network. And your proxy project will also using some of your subnet of this shared VPC network. And because they are all in the same network, and they can communicate through internal IP address without route the traffic to the internet. So in conclusion, as what I just described, there's 3 things we have talked about it. what are the Apigee APIM security capabilities, and what is the architecture best practices, and what is the Apigee X. And first, Apigee is a platform for developing and managing APIs by adding a proxy layer to your service. And Apigee provides a facade that helps you to secure your backend service APIs. You can use different security mechanisms in an application. Apigee has out-of-the-box default policies to secure your APIs. For example, they have security policy and have a traffic management policy and a message level protection policy, as we described it before. Second, architecture best practices. You use Apigee as a proxy layer and use Google Cloud Armor as a web application firewall layer with Apigee, and add Recapture Enterprise. You get integrated security capabilities to protect APIs at multiple levels. Third, we talked about Apigee X versus Apigee Edge. And what's inside Apigee X, we demonstrated using an infrastructure architecture diagram. And we also talked about configure Apigee X in multi-regional environment and also in a shared VPC environment. In this demo, I'm going to show you how does Apigee X looks like. So if you see this demo project, I already configured Apigee in this environment. And what you see here is as we talk about, when traffic comes in is a HTTP external load balancer. This is the external load balancer. And behind it is a backend service, is managed instance group. The managed instance group, in this case, I have 2 VMs to handle the traffic. And so it will give you robustness, not 1 instance VM, but 2. And then I'm going to demonstrate called Hello World OAuth token. In this Hello World, I have a target API I want to invoke. But this API is protected by, it requires an OAuth token. And so I created 2 policies. One policy is called verify OAuth access token. Second is that remove header authorization. And then once these 2 policies are executed, it will hit the target API. And the target API give you the results and send it back. Here is the target API. It's a mock API. The intention of this API is nothing but just to give you the IP address back. Say, here's the IP address, I'm hosting this API. But this, if you want to get this information, it is protected by OAuth token. So let's do an experiment. I invoke this API and immediately got rejected. The reason is that it's saying I have an invalid access token, simply because I have no token at all. Then what I did is that I create an app. And this app is saying I needed to invoke this mock API, and please assign me the client key and the client secret. So later on, Apigee will track my application invoked how many times of this mock API. And also, because of the client key and the client secret, I'm able to use that information to get an OAuth token. So in this screen, you can see, I actually did not share with you is that I already deployed an OAuth token generator and also the proxy inside Apigee. And if I supply it client ID, which is client key, and client secret, and through an HTTP post call, I will be able to get a bear token or access token, just like that. And the token will expire in 60 minutes. Then when I use again, I invoke this API. This time I pass an OAuth token. And indeed, you are able to see all the IP address currently hosting this MARC API. So that is how does the OAuth token works and how can you use it to protect your downstream API. Second piece I'm going to do is I'm going to create what's called spike arrest. Spike arrest is that to protect my downstream API, I set some limits, say how many times you can, I set some limits so to allow you to invoke my API to address the spike issue. Again, you can see I have in addition to the previous two policies, now I added a spike arrest policy. And initially, I set the rate as 30 calls per second. So certainly, that should not be a problem when you invoke an API when I do a demo. But what if I change the rate to 1 call per minute? So think about that. If I send 2 API calls, and within this 1 minute time frame, the first one will pass through, but the second one will be rejected. As you can see, the results here is that the authorization token, the first call is successful. It gives me back the IP address, but the second call, it tells me I have a spike arrest violation. And because I only allow to invoke once in 60 seconds, 60 minutes, sorry. And if you go to the debug screen of Apigee development environment, you will clearly see there's an error message. It say spike arrest violation. And if you look at the history, I made 2 calls. The first one is successful, but the second one has failed and returned with the status code HTTP 429. Furthermore, you can look at the proxy performance. Here, it can tell you how many traffic you have and how many of them are successful and how many of them are failed. And also tells you average response time. So let's say it even break down on target response time and versus proxy time, meaning the target combined with the proxy total. How much is it? As you can see, the latency on the proxy side is very, very limited. It's about 5 milliseconds in this case. And furthermore, it can tell you your traffic. You have, you not only have this hello world OAuth 2 traffic, but also you have something else. So that gives you a proxy performance. And I don't believe API gateway, another like a YT mentioned about, that product will offer that. This one probably is only offered by Apigee. You can get that kind of benefit, capability, and features. Furthermore, it gives you the traffic composition. It tells you top 10 proxy traffic and the top 10 developer traffic and top 10 product traffic. So based on these kind of data analytics, you will know which proxy has been used heavily and which one almost nobody is using it. And then further for you to guide you to optimize your API